magnet and their types and their properties, and we just know about the how do we demagnetize, how do we magnetize, then what are the types of magnet also we discussed, how to make the temporary magnet, those things we discussed. Can anybody can come and recall what we discussed last class? Can anybody? Any classes? Say, ask one question. What is magnet actually? Just to recall everything.
A magnet is a natural substance or natural substance which attracts three elements. They are iron, nickel, and chromium. And it has more attractivity with iron. Natural magnets are found in our earth, and artificial magnets can be made by the method of magnetizing a metal. There are two metals, from the center and from one point to another point. From one point to another point means the magnet is rubbed on the metal surface from one point to the end point, and in the center way it is rubbed from the center to the another point and from the other side to the center. Thus the metal can get magnetized and it can attract iron and other metals.
Then what is magnetic field? Do you know what is magnetic field? The last class I explained to you. Just look at this magnet. It's a very important concept. That's why I just want to recall you. So this is a magnet, bar magnet. So listen carefully. So it's a bar magnet. I just last class I just explained to you. I demonstrated you about this. It's a bar magnet. I keep the ion here, ion here. When I keep this, there is no attraction between this magnet and this iron nail. If I keep closer, there is no attraction. When I keep further closer, no attraction. If I keep close in certain region, it starts to experience force to pull towards this magnet. So this invisible region around this magnet is called a magnetic field. Do you all understand? When I keep this iron, when I keep close a certain distance, it starts to attract towards this magnet. This invisible region is called a magnetic field. Today we are discussing about the magnetic lines of forces. So my dear students, look at this. This is a bar magnet. So bar magnet, here it has two poles, north pole, as you know, north pole and the south pole. So the magnetic fields are almost from the outside of the magnet. We are going to discuss about what's happening inside the magnet and outside the magnet. Now I am going to explain you how magnetic fields are moving from outside of the magnetic field. So look at this. So the magnetic field lines, which is moving from north to south, outside of the magnet, very important concept. Just to keep this in your mind, the magnetic fields are always moves north to south pole in outside of the magnet. So you can easily remember that on switch, on, outside magnetic field. Magnetic field is the outside of the magnet, which goes north pole to south pole. It's a very important one, which will help you when you come to higher classes. So listen carefully. Outside of the magnetic field goes to north to south pole. Inside the magnetic fields also inside is there. I already told you how they become magnetized. I told you already. Inside each and every particles, each and every objects are made up of tiny particles like an atom. The atoms contain proton, electron, neutron. This electron, due to the electron motion, it is causing a magnetic field. And also, moreover, I want to tell you a very important concept. The point charge create electric field. The electric field also similar to the magnetic field. It is surround the electric charge is creating some invisible path, invisible areas created. But moving charge, the same charge is moving, it creates magnetic field. The charge is stable, it creates electric field. When the charge is moving, it creates magnetic field. Here, just look at this. The inside the magnet, what happens? Inside the magnet, the magnetic lines will move from south to north. Outside what? North to south. Outside of the magnetic field goes to goes to north to south. Inside the magnet, south to north. Where magnetic field strength is greater, whether it's either poles or center, magnetic field strength is much greater in where? Poles. Poles. Why? Did you think, I told that, the last day discussion, did you think why not be in the center of the magnet? Did you know why? Why is why it is the magnetic field being in the center of the magnet has become greater? Why? Do you know, my dear students? Actually, what happened? The magnetic field lines there, I told you already, the north to south pole, there are more concentric lines are forming like that. These all joined together. These are joined together in the poles. They are just joining here. Do you understand that what I am telling? See, for this magnetic field strength, these all will join there. So the magnetic field strength is more, magnetic lines are more concentrated in this part. That's why it's become more stronger. Okay, when I'm going to practically explain to you. You just keep this. Anyone just come in. Practically I will show you. So look at this, my students. So take the white sheet there. I'm going to fix it here. Anyone has to just come in. So I'm going to draw this outline of the magnetic. Just draw the outline of the bar magnet. Here I am finding north and the south pole. Listen, my dear students, I place it here. Next to see, this is a compass. Compass contains magnetic needle. See, I just keep this magnet. What happens? When you keep close to, I think those who are nearby, you can able to see, I think. When you keep this close to the poles, it starts rotating fast, very fast. When you keep it away, the deflection can be reduced. So which means the poles, the magnetic field strength is greater. When you keep it here, it just moves towards the where it moves, where it deflection, there you find out as the north. It's moving like this. So when I keep like this, it makes like the concentric circle. Like this, when I keep it here, it moves away from the magnet. Like this, you can keep the dot. Finally, what happens? It creates. Thank you. Finally, if we connect these lines, it creates such a concentric circle. The concentric circles are joining in this pole. So that's why I told the poles has more magnetic field strength. Next I'm going to tell you another property. You know that already. North and south poles are like poles are attractive or repulsive. Like poles are attractive. What is like poles? Similar. North and earth attractive or repulsive? Repulsive. North to south will be attractive. So this property already you know it. Next I'm going to tell that magnetic lines are imaginary magnetic lines are forming, but at the same time they do not intersect each other. Very important. By intersect means they do not go inside each other. For example, I am just telling to you the same. If I draw this line, suppose the magnetic lines are come here and then come there. When I keep the compass here, so this suppose for example, I just draw these two lines. These are the intersect each other, overlapping each other. When I keep the magnet here, at the same time, they do not show two direction. Do you understand, my dear students? If they overlap each other, if they interact each other, if I keep the compass, they do not show two direction instantly. Do you understand that? The magnet, suppose if you are going to somewhere, you are using, the magnet. Nowadays we have a GPS. In olden days, we didn't have GPS. On those periods, the people used what? compass, magnetic compass. If they suppose they miss their path, they keep the magnet, the compass. They want to find out where we are coming from or how to move from the place. The same time, the magnetic compass shows a two different direction. We are getting confusion, no? So this lines, this property do not match with the the magnetic lines of forces. Though already know that I told you remaining things. How to make permanent magnet? Which one is stronger, permanent or natural magnet? Which is stronger, permanent magnet or artificial magnet? Huh? Permanent magnet or artificial magnet? Which is stronger magnet? Artificial magnet or natural magnet? Artificial. What are the ways we can increase the strength of the magnetic field in artificial magnet? What are the ways? First, listen carefully. Suppose you think this is now it's a magnetic. You just imagine that it is a simply iron plate. If I want to increase the magnetic field strength, I need to increase the strength of the current. Next, I'm going to wind the number of turns of coil. These are the way we can use the soft iron core. These are the way we can increase the magnetic field strength. I hope you all understand that. Thank you. Today we have 3 birthdays.